All right, number 23. So you've got an absolute value expression, 23 minus 5y. And we're trying to figure out the smallest value of that expression. And we know that y is an integer. So let's let y equal 2. If you let y equal 2, you get 23 minus 10. Well, that's 13. That's a pretty big difference there. Difference being subtraction. If I let y be 3, I get 23 minus 15. So I'm getting a little bit smaller. Let's let y be 4. I'm just trying to get you to see the concept. 23 minus 5 times 4 is 20. That gives you 3. If you let y be 5, you get 23 minus 15. No, 5 times 5 is 25, minus 25. And that gives me a negative 2, but absolute value of negative 2 is 2. Now look what happens when you go back to y equals 6. Y is 6, you get 23 minus 6 times 5 is 30. So 23 minus 30, that's negative 7, it would be 7. So looks like the smallest possible value is y equal 2. Now number 60. So you've got this table, and let me see how I can illustrate this. Okay, I'm going to do a table 4 by 4. Now that's got 16 entries because you take the number of rows times the number of columns. That's got 16 entries. And if you look, I can see this. Of course, this tells you nothing, the diagonal, right? Because that just tells you the distance between A and A. Okay, so if I take 16 and subtract off 4, that gives me 12. Now, do you agree that these entries are the same as these entries? They are. So, how many unique entries do I have? You would take this 12 and divide by 2, and that would be 6. So in our problem, we've got 30, I believe. 30 cities. So 30 times 30 gives you 900. So that's how many entries you have. Now take off the diagonal, because the diagonal is just mapping to itself. So how many entries do you have in the diagonal? It's going to be however many rows or columns you have. So in this case, it's 30. So you subtract that, you get 870. And then take 870 and divide that by 2, and that's going to give you 435.